Hi everyone, we are still busy with June exam 2025 paper 1, and we are about to continue with question 4.1.3. We are looking at question 4, which is equations solve for x in each of the following, and we are now going to look at 4.1.3. This is a pretty straightforward equation, meaning it's not really intimidating. These exponential equations where our exponent or our unknown is in the base, but our exponent is a fraction or rational number, we simply need to get back to our exponent being a 1, right? Because we're wanting to know what is the value of x. We don't want to know what is the value of x to the power 2 over 3 or 7 over 8 or 1 over 4. We simply want the answer to the value of x to the power of 1. So if I want to take x to the power 2 over 3 or x to the power 4 over 5 and convert it back to an exponent where I have x to the power 1, I simply need to take the fraction and multiply it by its reciprocal. So it's the reciprocal concept or method that you need to use here to get rid of this fraction, right? And before I get there even, I'm still going to treat this as I would any other equation where I have a coefficient. Remember, I want to solve for the value of x, and if I want to get x isolated, I need to make sure that I'm rid of everything around the x. And at the moment, the thing that's around the x is still its coefficient. So I'm simply going to divide both sides by 3 to get rid of the 3. So that will then cancel. I'll be left with x to the power 2 over 3. And 27 divided by 3 is 9. So now I'm going to use the reciprocal of 2 over 3 and I'm going to raise this power to a power. So I'm going to use exponent laws. And if I raise a power to a power, I simply need to multiply those exponents. And I will need to do the same thing on the right-hand side. So if you are familiar or if you're comfortable, confident doing these types of problems, you would already have written, not necessarily, but you would have written the 9 as a power, in other words 3 to the power 2, because we know that we're going to have to raise both sides to a power, and raising 9 written as a power already to another power, it will just make that calculation simpler. But we will just, we'll leave that for now, and we'll just follow from where we are now. And I'm going to take x in the next step to the power 2 over 3, and I'm going to raise it to its reciprocal, which is 3 over 2. And I'm going to take 9, and I will also raise it to the same thing, which is 3 over 2. So these fractions, 2 over 3 and 3 over 2, they will cancel, or they will divide into 1, leaving us with an x to the power 1, which is what we want. On my right-hand side, I'm going to write 9 as a power because that will make it easier to raise it to the power of 3 over 2. Some of you had some creative ways of dealing with this. So this is only one approach or one method of doing this type of problem. But some of you recognized over here that if I've got 9 to the power 3 over 2, that is the same as saying the square root of 9 to the power 3. And 9 to the power 3 is some number that if I square root it, I get the same answer as what we're going to get here now. So let's see what that will be. If I write 9 to the power, or write 9 as a power, it would be 3 to the power 2 raised to the power 3 over 2. So x will just be tagging along until we simplify our right-hand side. So that will be 3 to the power 2 times 3 over 2. So that will be 2 over 1 times 3 over 2, which will just be 3. So that is in fact 3 to the power 3, which we know is 3 times 3 times 3, which is 27. So in other words, those of you who did this, 9 to the power 3 over 2, which is equal to the square root of 9 to the power 3. 9 to the power 3 is some big number, which if I take the square root of that number, I will get to 27 as well. And just to break this down even a little further, maybe, I mean, if you have a calculator, this will not be an issue, but this of course would be the square root of 9 times 9 times 9, which is the square root of 81 times the square root of 9. So the square root of 81 is, of course, 9. The square root of 9 is 3, so 9 times 3 would be 27. So that of course, you don't need to go through all of this PT because your calculator can do it for you, but that's just to show how we got to the same answer over there. 4.1.4, we have an exponential equation. 2 to the x plus 2 times 2 to the x minus 1 is equal to 2 to the x. The nice thing about this is that our bases are all the same already. Notice that I do not need to, and this is a mistake that is made often, I don't need to take out a common factor. In fact, I can't, because this is a product. When I have a product between two factors here, something being multiplied with something else, I don't take out a highest common factor there. I can just multiply the two stuff. In fact, this would be the application of law number 1 in laws of exponents, where I've got a power multiplied by another power. The powers have the same base, so I can simply add the exponents and keep that same base. So there's a few ways again of doing this. I'm just going to follow that simple approach. So I've got a base 2 to the power x plus 2 times base 2 to the power x minus 1. I will keep my base and I'm going to add my exponents. So x plus 2 plus x minus 1, and that is all equal to 2 to the power x on the other side. And now again, immediately I have the same bases on either side of the equation, which follows then that my exponents must be equal to each other. So I can immediately then say that I can say here therefore x plus 2 plus x minus 1, which is my exponent on the left, is equal to x. And then simply a matter of adding up like terms. I've got x plus x on the left here, so that's 2x. And I've got 2 minus 1, which is 1. So let's just simplify. We can see things a bit better. I've got negative 1 on the right-hand side. I've got 2x minus x, which will give me x. So x is negative 1. Again, there are a few ways in which one can approach this. I won't look at all of them here, but this is basically, for me, the simplest approach to this. I might just add that what some of you did would be to, once you have gone from the step over here to this one, you guys added up and simplified this exponent immediately before dropping your bases. And then just another thing, this is a common misconception. At this point over here, in order for us to go from this step to this one, where we say therefore the exponents are equal, it is not equal because we divided both sides by 2. You did not divide away the bases. The bases are still there. It is just at this point we have worked to a point, not in this case, we didn't really work to it because it was already set up that way, but because our bases are the same, it follows that the exponents must be equal. We did not, so you should not do this. You should not, that's 2 to the x plus 2 plus x minus 1 equals 2 to the x. We don't do this. This is not what's happening. Okay, so we do not divide the bases away. The bases are still there. We have simply moved our calculation now from what it was over here, and we are now simply moving our calculation to the exponent, so we are able to find out what value of x makes this true. So I hope that explanation helps.